Why is my computer slow? By Yuri Megalev for Geek Out 365. We're going to talk about perception of performance, types of computers, user experience components, analysis tools, and common solutions for your performance issues. Perception of performance. So when you take your regular personal computer, what indicates good performance on it and what indicates bad performance on it? In order to understand that, you have to answer the following questions. How long does it take to boot the computer? From the time you press the power button until you get to the login screen. How long does it take to log in when you type in the password until you get to the start menu? How responsive is the start menu and other drop-down menus? How fast do applications start? How responsive are letters being typed in the word processor? And some things that are very hard to measure, like letters being typed in the word processor. How fast is scrolling in documents? Again, another thing that's really hard to measure. And yet, when you scroll in documents, it shows you whether the computer is fast or not. Does the video run choppy or smooth? Video you can measure, but oftentimes video is what shows you whether the computer is fast or not. And are there freezes in the applications? The applications freeze often. That means the experience is bad for you. That means you're frustrated and you need to change something. Now, if as an engineer you were to improve your experience, okay, by changing some technical parameters, when are you going to feel it? Well, there's a white paper out there that says that the user will only feel an improvement if the change is 20% or better. So if you have 100-second login time, which is pretty bad, and you improve it to 95 seconds, it doesn't matter. Okay, if you improve it by at least 20 seconds to 80 seconds, the user may feel something. But usually you need to have a nice big improvement in order for the user to feel something, even more than 20%. I would say 50%. So in order to understand how to measure performance in computers, we need to understand the types of computers that are out there. There's physical laptops, and they may have one hard drive. They may have limited memory, usually anywhere between 4 and 64 gigs of RAM. They may have a dual-core, quad-core processors. Some, like MacBooks, have memory soldered on the motherboard, and also the hard drive soldered on the motherboard. So you cannot do any upgrades, something to keep in mind. And all memory and CPU in the hard drive and space on the hard drive is dedicated to one user. It's very important. Only one user uses this machine. Physical desktops, very similar to laptops, except much more upgradable. You could put in more hard drives, more memory, more processors, but still, all of these processors and hard drive performance and memory is dedicated to one user. So those were physical computers. Now let's talk about virtual computers. Remote Desktop Services Host. Remote Desktop Services Host is this technology from Microsoft that allows a server to be divided into pieces. And these pieces, they are presented to users as desktop looking. So they look like desktops, but in reality, all users share pieces of this one server. And these pieces are called sessions, okay, or remote desktops. Usually, there could be anywhere between 32 to 256 gigs of memory in a server. It could be more. Maximum amount of memory is a lot because servers usually can take a lot. The server is backed by storage area network or network attached storage with multiple hard drives, mechanical or flash. There are multiple processors, and the processor speed is pretty fast. And what's important to remember is that with the RDSH, all the resources are shared between all the users on the server. So when one user opens up an application, another user's memory is being affected by that. And the solutions for RDSH are being made by Citrix, VMware, and Microsoft. Finally, we have virtual desktop infrastructure. And virtual desktop infrastructure is kind of somewhere in the middle between a physical computer and RDSH, in the sense that each user gets his own virtual computer, right? There's no sharing like in RDSH, but the computer is virtual, okay? And the computer has virtual resources. Because the computer is virtual, it's easier to assign resources to that computer. So typical memory is between 2 and 32 gigs of RAM. It is backed by storage area network or network attached storage with multiple hard drives. There could be multiple processors, and the speed of the processor could be pretty fast. You can configure typically 2 to 8 virtual processors, and just remember that all of the performance of the virtual computer is dedicated to the one user. So it's similar to a hardware laptop or desktop, but it is virtual, which is similar to RDSH. So this is kind of an in-between solution that seems to be lately the sweet spot for a lot of applications. And the technologies are made by Citrix and VMware. Microsoft also has it, but it's not that popular. So now that we understand what the desktops and the computers that are out there are, how is it that we measure these computers? We'll talk about the analysis tools later, but now we're going to talk about the parameters or experience metrics that we need to understand in order to understand the user experience on the computer. First, we need to talk about the so-called front-end metrics. And these are metrics which directly influence the user experience. For example, if a user is logging in on the average in 30 seconds to his machine, it's okay. But when the user takes 5 minutes to log in, and I have seen personally when that happens, the user may go away, get a cup of coffee, come back, and the desktop still has not logged in. Okay? That makes the user frustrated and think that the computer is slow. So user login delay is very important, right? It is from the moment that you type in the username and password until the Windows Start menu shows up and it is clickable. Okay? So how do you improve user login delay? Well, you need to address the page file, the memory, and the CPU first. And once you address those parameters, you need to address the storage. And we'll talk about the technical metrics and how to do that later and common solutions. But when you've addressed all the technical parameters and everything is running fast, but your user login delay is still slow, you would need to look at group policy objects, scripts, and printer drivers, and also antivirus drivers that could be affecting your user login delay experience. Antivirus drivers, for example, are known to do scanning as soon as you log in, and therefore can slow down the session. Application load time. Application load time is from the moment you double click on the application until the application opens in its initial screen. The best time is 3 seconds or less. That's what a user is expecting, the application to open very, very quickly. If it opens in 4 to 10 seconds, it's barely acceptable, and anything longer than that, at that point, is going to be subpar. The experience is going to be subpar. So how do you improve application load time? Very similar to user login delay, you need to address the page file. You need to make sure that it's very low. You need to make sure that the memory is enough for the user session. The CPU is enough. The storage is fast. If the application load time is still slow, you need to make sure that the antivirus is optimized. If it is a agent-based antivirus, then you need to make sure you address all the optimizations that the manufacturer recommends for VDI or for RDSH. If it is a agentless antivirus, then you already are ahead of the game, because you're going to be 30% less on IOPS hit. So agentless antivirus would be recommended. So that's how you would address application load time. The last front-end metric is called applications not responded, or ANRs. So when Windows detects that an application is freezing or crashing for various reasons, it will generate this message in Task Manager. Many tools will detect this and put this as one application not responding. Okay, so we want to have maximum of one application not responding per user per day. Think about it. If one application crashes during your day, maybe it's a fluke. Maybe it's okay. But if 2 times it crashes, or 2 different applications crash, 3 times and beyond, that's when your experience goes down and you start thinking that the desktop is slow. How do you improve that? The main thing to improve it is make sure you reduce the page file size. You have enough memory, enough CPU, enough storage, and enough storage performance. And then, if there's still too many crashes, make sure you have the latest updates installed for your applications, and you optimize the application specific to the application. Some applications have specific settings, which we'll talk about later for common applications. So user login delay, application load time, and applications not responding are these front-end metrics that allow you to measure user experience to a degree where you can actually quantify it. Backend metrics. So the front-end metrics rely on the backend metrics. Why are they backend? Because these are technical metrics which, if they're good, will affect the front-end metrics. Okay? In a sense, it's similar to how in economics, there's lagging indicators, which in our case is front-end metrics, and there's leading indicators, which in our case is back-end metrics, for those of you who are into economics. So let's talk about back-end metrics. Page file utilization, percentages, and megabytes. When Windows does not have enough memory, does not have enough RAM, it starts to use hard drive space for storing memory data. Hard drive is much slower, so we don't want this to happen. Okay? So what should page file utilization be? It should be less than 2%, or less than 500 megabytes in utilization when you talk about Windows. Okay? If it is anywhere more than 2%, or 500 megabytes, you're going to get sluggish performance, you're going to get sluggish front-end metrics, application load time, user login delay. You're going to get a lot of applications crashing. So how would you improve page file utilization? The most important thing is you need to add RAM, add memory. If you're on the physical machine, you add physical memory. If you're on the virtual machine, you add virtual memory. After that, SSD storage is essential. If you have fast flash disk, your page file will be running quickly. But of course, this is a secondary bottleneck, right? The storage usually. Also, in Windows, set it to minimum size, but do not turn it off. You don't want to turn off the page file in Windows. Windows always relies on the page file, even if you have enough memory and everything, and you think, oh, let me just turn it off. I don't need it. Do not turn it off. Set it to minimum, but do not turn it off. Memory utilization is a corresponding metric. It's not as important as page file, but it is still important. We want to make sure that it is less than 75%. As soon as it goes above 75%, the system will start to use page file much more, and that's when you get bad page file utilization percentages. Okay? How do you improve memory utilization? Again, just add RAM. CPU queue and CPU utilization. For CPU queue is the most important processor metric because when threads are basically commands on the processor, when they have to wait in the queue because another active thread is being processed by the processor, that's bad. Okay, you want the queue to be 2 or less per each processor core. All right, so 2 is the magic number. If you have anywhere between 2 and 3, it's okay, but anywhere beyond that, it's subpar. All right, so how do you improve the CPU queue? This may seem counterintuitive, but you need to resolve high page utilization first, page file utilization first. Why is that? Because when the system has to move memory from regular memory to disk to the page file, it uses extra CPU, okay? And therefore, once you solve your memory issue, your page file issue, your CPU queue will go down. Now, it may still not go down to acceptable levels because you have applications that use the CPU a lot, but it will go down a little bit. That is why it's very important to address high page file utilization first, then you address the CPU queue by adding another CPU or two. And in a virtual environment, it's okay to add an odd number of CPUs. Finally, if that doesn't help, you have especially a lot of high graphics intensity, and I'll talk about that later, but if you have a lot of high graphical applications, you may want to add a protocol accelerator card or a hardware GPU card to offload your graphics and your protocol. Okay, and that card can be added to desktops. It could be added to the servers that RDSH runs on and virtual desktop infrastructure runs on. Usually that card cannot be added to laptops, but for laptops you can buy a laptop that already has a GPU, extra GPU built in. That would be a gaming laptop. CPU utilization. This is the second most important metric: how much CPU is utilized versus total CPU available. Well, what you want to have is under 50% during a 1 hour interval. If you have between 50 and 80%, it's okay, but over 80% is not good. How do you improve? Same thing as CPU queue. You need to resolve high page file utilization, then you need to add CPUs. If that doesn't help, you need to add hardware GPU offload and protocol accelerator offload. Okay, and by protocol I mean in the virtual desktop or RDSH environment, you have protocols that are responsible for providing you access to your virtual desktop or your remote session, which would be RDP protocol or PC over IP or HDX protocol. So if there are cards available, for example, there's a card available for PC over IP protocol to accelerate that specifically, right? Card from Teragici. And if you get that card, you will offload the processor, and therefore your overall processor utilization will go down. Disk queue and disk IOPS. So disk queue is the most important storage metric for performance. Why is that? Just like in the CPU queue, when you have disk input out requests, which are basically commands, which are basically, write me letter E to this Word file, okay, or write me letter A to the Word file. That's an I/O, right? And that would be a write I/O. So when you have these input output requests, they have to wait in queue because another active request is being processed. That's not good. So anytime there's a queue, it's not good. However, in this case, you want the queue to be 0 as much as possible. If your queue is 1 or 2, it's barely okay, but beyond 2 is not good. All right, so as close to 0 as possible. How do you improve the queue, this queue situation? Again and again, you need to resolve high page file utilization, because when memory needs to be moved from RAM over to disk, Okay, the CPU does that, and of course the CPU queue is affected, but then memory moves over to disk, and now disk queue is affected. So the more page file is being utilized, the more disk queue is being utilized. Okay, now of course, after you resolve your high page file utilization, you may still have a disk queue problem. In that case, you need to address it by replacing your mechanical disks with SSD or flash. That is the most effective solution after you address your high page file utilization. Disk IOPS. Disk IOPS is the second most important metric for disk performance. So disk IOPS are actual requests that sit in that queue, right? So that's the IOPS. That's the requests or commands. Give you an example, an average Windows PC generates 20 to 35 IOPS in idle state. During login, Windows may generate up to 150 on average IOPS, but then it goes down after that. I've even seen Windows generate in the neighborhood of 900 IOPS, okay? But that's a very, very, for a very, very, very brief period of time, literally, second or two. And it goes away quickly, usually during the logons. So that's something that you have to watch also. How do you improve that number? Again, you resolve high page file utilization, and then just like with disk queue, you replace the mechanical disk with SSD flash. That will resolve your IOPS issues. Graphics intensity. So graphics intensity is not as critical to your performance metrics as the front-end performance metrics and the other back-end technical metrics that we were talking about. So graphics intensity is more informational for you. Okay? So what is graphics intensity? Graphics intensity is how many times Windows has to call its graphical subsystems. So anytime Windows has to display something on the screen, like a picture or a dialogue, that has a border around it or something that's graphical, that's a graphics call, right? And that's considered one GDI. You want to have less than 100 for GDI, right? If you have 100 GDI and it's constantly above 100 and it's constantly like that, you need to understand that you are using higher than normal graphics. If you have above 1,000, that may indicate either a GDI leak or the fact that you're running something like a DVD movie, or the fact that you're running a professional graphical application like Photoshop or AutoCAD. Okay. If you have a GDI leak, there's a link on the screen. You could try to troubleshoot it through that link. But also, sometimes you have applications that are coded poorly. I've seen a application which was a staffing database at a company where it was generating in the neighborhood of 6,000 GDI. So I was wondering, are they running, Blu-ray movies or something like that? And I looked at it and it was just a database with text and fields. So I said, why is that doing that? And we called the manufacturer, and it turns out that the manufacturer just didn't code it properly. And it was making all of these Windows calls to graphics, which it didn't need to do for this type of application. So sometimes it's unfortunate, but the developer of the application is responsible. So you may want to call the manufacturer of the application. So how do you improve GDI? How do you make it less? Well, graphics are affected by CPU and memory in general. For example, if you have any kind of graphical applications like Photoshop, you need to have a high clock speed CPU. Okay, so even if you have multiple CPUs, but they're 2.4 gigahertz, it's not going to do it when you have something like Photoshop. You need at least a 3 gigahertz clock speed of processor or higher. And then you can start increasing more processors. You also can improve it by providing, and I already talked about it, but providing a hardware GPU offload hardware acceleration card. And you could do that for your desktop, You could do that for the RDSH server, and you could do that for a VDI server also. For a laptop, you can buy a gaming laptop. For example, ASUS makes a gaming laptop called Republic of Gaming ROG that has really advanced NVIDIA GPU cards built into the laptop. They're very bulky, but if you require that type of thing, then you can buy it. For desktops, you could buy a mid-price NVIDIA GPU card. Don't go crazy. Unless you're running AutoCAD, you don't need the highest end GPU card. So you don't need to spend, $1,000. You could spend $500 or $200. For virtual computers, either VDI or DSH, NVIDIA makes special cards, right? You cannot use a regular consumer card to improve the speed of your graphics on your virtual computers. You need a special card, and they're called NVIDIA Grid Tesla M6. That's for the Blade servers, and then Tesla M10 or M60 for rack servers, and the older generations are called NVIDIA Grid K1, K2 cards. Finally, we're reaching last backend metric, and that is network. And network is applicable to virtual computers only. Why is that? Because when you use virtual computer, you actually pass your keyboard, video, and mouse data from wherever you're accessing the virtual computer from, let's say an iPad, to the actual virtual computer where it's located, where somewhere in the data center, right? So as a result, you are using the network to pass the keyboard, video, and mouse data to you. And therefore, you have to be worried about the network. When you have a physical laptop or desktop, everything that you are doing is local, so you don't need the network. I mean, you do need the network, but you don't have to worry about it for your particular user experience as much. You only have to worry about it from an internet perspective. But here, with virtual computers, we have to worry about it from an overall user experience perspective. Because if the network is slow, you're going to get certain things happen on your machine. For example, you may have some dots on the screen, right? You could see, or you can have the mouse choppy, right? You move the mouse and it doesn't move smoothly, it moves choppy. So you can actually see this. So what do you want to have your latency for your network? Well, latency less than 50 milliseconds is best, because at around 300 milliseconds, you're going to start having problems with video and voice. Before that, between 50 and 300 milliseconds, depending on the application, you can use video and voice. It might be a little choppy, but it'll be okay. And of course, if you go and look at typical latencies from one USA coast to another USA coast, it's about anywhere between 50 to 80 millisecond latency. So you can have the best latency available over the whole United States, right, for virtual desktops or RDSH. So you don't have to worry about it. And yet, even for something like India, USA to India, you're going to get 200 to 380 milliseconds. So you might even be able to run video to India, okay? So that virtual desktop that's coming from India, say to US, it can run video and still being able to watch it. Okay. In fact, I have a different video out there where I sit on an airplane and I try to log into my virtual desktop, and the latency was between 600 and 900 milliseconds. And of course, I could not watch any video, but I was able to work, and I was typing, and the type delay on the screen, there was no noticeable type delay. I was still typing, and I was working. So even at satellite connections, you could still do regular work except video and voice. So how do you improve the latency? Well, you need to measure it, and you need to talk to your network provider to get a better connection. All right. Packet loss. Packet loss is when you send data across the network, how much data is lost across on the way. You want packet loss to be less than 0.30%. Okay. Otherwise, what you're going to see on the screen is all kinds of dots and all kinds of digital artifacts and mouse drag. So how do you improve that? Well, one common solution is to replace the Ethernet cable going from your access point over to the wall jack. Sometimes they're bad cable. You need to troubleshoot Wi-Fi. You need to move to a different area of the room or building. You can update the Wi-Fi drivers or replace the card. You can also troubleshoot the cable that's going from the wall jack to the switch and the switch and router port and everywhere along the path of the cable. One other important thing is do not use VPN to access virtual computers. Usually for both RDSH and virtual desktops, there are solutions that allow you to avoid using a VPN. Usually both Citrix and VMware provide you with their own solutions to log into the virtual desktop directly. This is a typical latencies in the United States from different cities. This is from AT&T as of the creation date of this presentation. You can see that the highest latency you could get is from Seattle to Washington, D.C., all the way to the right. You can see it's about 68 milliseconds. So it's not bad, considering that I said that you want the latency to be ideal less than 50. At 68 milliseconds, you're going to be running just fine. So now that we discussed the types of computers that we have and also the types of metrics that we're measuring, so what did we use to measure these metrics? What tools do we use? Well, there are a number of tools in the market, okay, and they all do different things. You know, they all do similar things, but they also do some different things. The oldest tool and the first tool available out there was Liquidware Labs Stratusphere UX. That was the first tool on the market to do this. It is still, I consider, to be the best tool out there. It can evaluate also login process components and GPU metrics, and also has an assessment module where it can evaluate your physical desktops in addition to your virtual desktops and the RDSH. Okay, specifically for assessments. Lakeside Systrack is a competitor of Liquidware Labs that came on the market soon after. One thing it can do is it can measure Macintosh computers as well as PCs, and it is also endorsed by VMware because VMware uses it for its free assessment tool online. ControlOp is a new player. It's cloud-based. It can evaluate login process components really nicely, and it has a lot of interesting features. It can deploy scripts widely. That white paper where I said the user login delay on the average was 30 seconds, that was a ControlOp white paper. So very interesting offering. NextThink is another cloud-based model. The one interesting thing about NextThink is that it's the only one that has the user feedback module integrated, where you can actually run these campaigns where you can ask the users what are they experience is on their virtual and RDSH desktops. Okay, so they can just fill out a little survey, and then you could track the results of the survey. So you don't have to do a separate survey, but you can just do it integrated inside the tool. So that's an interesting feature. However, it does have some other deficiencies. So those are the four big tools. A lot of them have free evaluations, and I'll talk about it in a moment. So you can download the evaluation and you can run it, and you can actually analyze your physical machine with pretty much any one of these tools, or your virtual machine with any one of these tools. There's also the good old Windows Performance Monitor when you're inside Windows. A lot of these parameters that I talked about are available in Windows Performance Monitor. What is not available in Windows Performance Monitor is the front-end parameters. The user login delay, the application load times, and the application is not responding, the count. That is not available in Performance Monitor, unfortunately. So you need to get these other tools in order to track those front-end parameters. On the Mac, you can look at the Mac Activity Monitor. Same thing. A lot of the metrics, technical metrics that I talked about are available, but the user experience metrics are not available in Mac Activity Monitor. And here for Liquidware Stratusphere UX, here's how you can get it. You can go to their website. Okay, you could click this link right here. You could fill out the evaluation form, with whatever that you like, whatever information that you like, and you can put in any email address. It doesn't matter. They don't send you anything by email. And then you hit submit, and you're gonna get a link to download the evaluation version. The evaluation version is good for up to 5 machines in 10 days. And that's plenty of time for you to evaluate your performance of your individual personal desktop or laptop or your virtual desktop infrastructure for a couple of machines. If you want more than that, then you need to contact your Liquidware partner like CDI, or you could just do it yourself directly and ask the Liquidware salesperson to give you a license for 250 machines for 30-day evaluation license. Okay, and here's a link down below where you can watch training videos to understand how to use the tool. One important thing is if you're running it just on your specific laptop or desktop, you don't want to be running it on your laptop if you're evaluating your laptop. You want to run it somewhere else, right? You can spin up a VMware player or VMware workstation or VMware Fusion and run the appliance there, and then evaluate your laptop, which is a separate machine. When you're downloading Liquidware, if you're downloading it for VMware, you can see here on the left, you choose VMware, and then if you're downloading it for personal use, here's a link down below, the download link right there. And if you're downloading it for server purpose, you want to download both the hub and the database appliance. Okay, if you're downloading it for Microsoft Hyper-V, here's a link for the personal use, and for the for company use, you want to download the hub appliance and the database. So now that we talked about how to measure it, what tools to use, and what types of computers we have, what are some common solutions to the types of computers that we have? Common solutions to performance issues. Laptop. It is important that you reboot your laptop every week. Don't let it just go to sleep. Why is that? Well, Windows, every time Windows goes to sleep and comes back from sleep, and every time Windows works, it fragments the memory. And with time, it fragments more and more and more, and you can't really defragment it. The only way to defrag your memory is you reboot the machine. Okay? So make it a habit once a week to reboot your machine, and you will have much better performance overall. Okay? Same thing applies to a physical desktop here. All right? The other thing you want to do is you want to adjust your antivirus scan to scan the whole computer once a month when you're not using the computer. Don't let it scan every day. You don't need these quick scans. You only need to scan it once a month because you do have real-time protection on all antiviruses out there. Whereas as soon as you open a file, it will detect that there's a virus and will kill it. Okay. You also, for both laptops and desktops, you want to set Windows updates to be done automatically, but only when you're not using the computer. I think by default it goes up and it sets it down to 3 a.m. in the morning. Make sure that that's when you're not using the computer, and so that the updates, when they're done, they don't interfere with your work. For laptop, add the maximum amount of memory the laptop allows. Okay, do not buy a laptop with less than 8 gigs of RAM anymore. It doesn't make sense. I understand that there are cheaper laptops, and yes, if you do need it for very specific purpose, you just want to kind of use the word processing and very light browsing, it's okay. But any type of serious computing, 8 gigs of RAM at this point is the minimum that you need. Do not skimp and do not get less than that. Also, make sure when you buy a laptop that your hard drive is SSD or flash. At this point, the whole industry is moving toward SSD, and if you have a mechanical hard drive, it will not be performing fast enough. Modern operating systems require SSD. When Microsoft makes their software at this point, they assume that you'll be using the faster SSD hard drives. Finally, once a year, you want to reinstall the operating system with all the applications fresh and put the data back on your computer. I know it's a major hassle, but the longer that you use your operating system and applications, the more stale it gets. Memory fragments, unnecessary stuff gets installed. So once a year, you want to either do it yourself or ask your friendly technician, or if you're in the company, ask your IT staff. But bottom line is you want to rebuild it once a year, and you will be running nice and quick after that. Okay? For physical desktop, very much similar recommendations as for a laptop. The only thing is the memory. On the desktop, you can put in a lot more memory. Obviously, the more the merrier. You want to put in more as much as possible. For the hard drive, you also want to have SSD hard drive as your primary hard drive for drive C. You can add a mechanical hard drive, but only if you're using it for backups. And also, again, for desktop, reinstall your operating system once a year. For virtual computers, first, let's talk about the virtual desktop infrastructure, or virtual desktop. Just like on the physical side, you want to reboot all your VDI desktops every week, once a week. Or if you are using non-persistent desktops, then you don't need to do that, because every time non-persistent desktop is logged off, it is destroyed. And next time you log in, you get a fresh one. So essentially, the reboot is already done for you. Okay. You also want to rebuild the desktop image at least once per year, similar to what I recommended on the physical side. You also want to use agentless antivirus, because it's going to give you improving the speed by 30% on the IOPS. That is a big number. So if you can help it, you need to buy either Trend Micro Deep Security or McAfee Move, or one of the number of the other agentless antiviruses out there. A lot of them offer it now. Symantec, Bitdefender, Sophos offers it now. So just go to your antivirus vendor and ask specifically for agentless for VDI. That's what you need to ask for. Trend Micro, by the way, Deep Security, is the oldest and the most developed one of all. If you're not using agentless antivirus, in spite of my recommendations, you want to adjust the antivirus to do scheduled scans only once per month, and you also want to follow manufacturer tips for VDI. For example, Symantec offers tips like turning off quick scan, not scanning after definitions update, and using the so-called reduced definitions package size, where when you download definitions, they're much smaller, and therefore you're not impacting the network and impacting the speed of your virtual desktop. You want to set the Windows updates to be done automatically, but only when you're not using the computer. Time and time again, I see users scheduling Windows updates to be done during the day, which is impacting the speed of their computers. You also want to add the maximum amount of memory that you can afford per virtual desktop. At this point, it does not make sense to do less than 8 gigs. Most applications out there, most nice, YouTube watching and everything that the normal user does requires 8 gigs of RAM at a minimum. Okay, so do not skimp, do not give your users 4 gigs of RAM. Also, make sure that your hard drive is SSD flash. Your VDI server administrator, of course, is going to be responsible for that. But at this point, again, VDI runs much better in Flash. So make sure that you get that. For remote desktop services host, similar recommendations as for VDI apply, except they apply to the particular server. You want to reboot it every week. You want to rebuild it at least once per year. You also want to use agentless antivirus if your server is not a physical machine, but a virtual machine. And the server could be either virtual or physical. Again, same recommendations for RDSH. If you're not using agentless antivirus, make sure that you do staggered scans and make sure you follow all the manufacturer recommendations for optimizations. When you're doing Windows updates, make sure you do it automatically through something like WSUS or SCCM. And when less people are using the server, add memory. Make sure your hard drive is SSD and flash. And of course, like in any RDSH environment, you can add more servers and distribute the user sessions across those other servers. So you distribute the load across many different servers. So that's what you would like. That's what you want to do. So what about optimizations for common applications? So let's talk about the two most common applications that I see in my work: Outlook and Google Chrome. So Outlook is probably the worst application for performance that's ever made, because in all of the troubleshooting that I do of performance, Outlook comes down as the number one hog. Okay, it oftentimes beats Google Chrome. So it's between Google Chrome and Outlook, but Chrome is a lot more optimized. So for Outlook, what is important? When you look in the inbox folder in Outlook, you should not have more than 1 month of email in there. Okay? You also should not have more than 100,000 messages in there. And for those of you who think 100,000 is a lot, well, I see this all the time. People just forget. They let their inbox folder accommodate more and more and more and more messages. It becomes that they're storing messages for the last 10 years, and there is definitely more than 100,000 messages in there. Don't do that. That will slow down your Outlook to such a degree that no matter what troubleshooting you do for your virtual desktop or physical desktop or whatever, it's not going to help your Outlook. Okay? The only thing that's going to help your Outlook are these tips. If you are on a PC, you would want to enable auto archive for Outlook and archive these messages to a different local PST file. That way you don't have more than 1 month of email in your inbox. All right? Because all that other email is in your PST file locally. All right? On a Mac, you can move the messages from your inbox once a month to a folder specified as on my computer. That way all of your older email is in a separate folder on your computer, right? It's not cached from the server. If you have Outlook 2013 or higher on a PC, you want to adjust your Outlook cache, and it's in the account setting where you specify that you want to cache. Right there's a slider there, and you want to slide that slider to only download 1 month of email. By default, I think it's set to 12 months of email. Don't do that. Set the slider to 1 month of email. Every 3 months, I suggest that you rebuild your Outlook profile, or it's called database on the Mac. If you don't know how to do that, you should ask your technician, or you can Google it. But that does improve performance. You also want to remove shared calendars and shared mailboxes of people you no longer need to view. If you have your former colleagues that have already been gone, for 2 years, you still have his calendar in your Outlook, you need to remove it. It's slowing down your Outlook. Okay. Finally, you should disable Windows search indexing on Windows. Now, if you disable it, you're going to not have ability to search within documents by text. Okay, you can search by file names, but you cannot search within documents. So it's a trade-off, right? But because Windows search slows down everything tremendously, it's a trade-off that a lot of people, including a lot of my customers, go for. So those are the Outlook recommendations. If you follow these recommendations, your Outlook will run much, much, much better. For Google Chrome, do not open too many tabs. Every time you open a tab, it's like opening up another application. Okay, especially when you open tabs that there's a flash video or regular video or Java, those will slow down your system. You want to open Chrome Task Manager, which is a menu option in one of the Chrome menus, and in there you can sort by CPU or memory, and you can just close the tab that have the highest CPU and memory. You may not need those tabs. I've seen people run 100 tabs. In fact, I admit I run 100 tabs myself occasionally, but I have enough memory. I have a lot of memory, and I know I'm not exceeding the memory. If you don't have enough memory and you run these tabs, you're going to suffer. Everything is going to be crawling. So make sure you look for the highest memory utilization CPU tabs and close them. You also want to disable unused Chrome extensions. You go in there and something that you haven't used or you downloaded that's still wasting your memory, maybe some sort of an RSS feeder that you don't use anymore, close it, disable it, okay, in the extensions area of Chrome. Finally, if you're running on the virtual desktop, you want to disable hardware acceleration. And you can Google for all of those things and you will be able to find how to do this. So hardware acceleration is that feature that Chrome has if you're running on the physical machine. And a physical machine, it can be useful because it can use your GPU. But on the virtual desktop, if you don't have the NVIDIA card, if you don't have that GPU accelerated card, and you're running hardware acceleration, it's actually slowing down your Chrome. So you want to disable that. So what we talked about is what is the perception of performance and how to evaluate performance on physical and virtual machines. We talked about the metrics, the front-end metrics that are responsible for the user experience and how the user feels his desktop is performing. And we talked about the technical backend metrics that basically feed into the front-end metrics and that are responsible also for user experience. We also talked about how you can find common solutions to problems of performance and how also you can use specific analysis tools to troubleshoot using those metrics that we talked about. Finally, we talked about optimizations in common applications. I hope you found this session useful. I would like to say special thanks to Chris Walker and Matt Boyadjian, whose guidance I used here. You can connect with me on LinkedIn, Yuri Magalev, on Twitter. You can connect with me on my personal blog, cloud-zebra.com. My user ID for YouTube is YM640. And you can also, of course, email me questions to my personal email, okzebra@gmail.com, or my work email, yuri.magalev@cdillc.com. Thank you very much.